All right, welcome to this explainer. Today, we're taking a look at a daily grind and figuring out how to turn it into a completely seamless workflow hawk. If you're anywhere in IT, SRE, or customer support, you already know the golden rule. The quality of your incident data entirely dictates the speed of your resolution. So, we're going to explore how to use Claude essentially as your AI pair programmer. We'll cover everything from structuring messy notes with prompt templates to generating root cause hypotheses right out of your raw logs, and even drafting those tricky customer-facing updates. Basically, we're going to automate the busy work and slash your triage time in half. Okay, you know the exact feeling. It's 9 a.m., you sit down, and there it is, this absolute nightmare of a vague, two-line IT support ticket just sitting in your queue. VPN keeps dropping mid-call. Fix it. Right. No device mentioned, no OS version, no timestamp for the drop, no error codes, nothing. When you get raw, unstructured input like this, the clock is already ticking, but you can't even begin to troubleshoot because, well, you have to play a game of 20 questions with the user first. What's really fascinating here is that this highlights a process problem, not an agent problem. Imagine you have two agents. Agent A gets the ticket, structured response, gathers the client version, shares a step-by-step fix. Awesome. But Agent B, facing that exact same ticket an hour later, they just reply, try restarting your laptop. Same team, same issue, wildly different user experience. Without standardized templates and structured data, your resolution quality is literally just a roll of the dice depending on who grabs the ticket. And that is exactly what we're going to fix using AI. Let's move into Section 1, Prompting the Perfect Ticket. You see, our very first goal, it's actually not to solve the issue yet. First, we have to force that chaotic user input into a highly structured format that our engineering teams can actually work with. A solid service ticket needs these four core components: the summary for a quick overview, steps to reproduce, which are absolutely vital for engineering, impact. This tells us the business severity, right? Is it just one person or is the entire finance department offline? And finally, expected versus actual results to give us the technical deviation. If you skip any of these, you're just creating bottlenecks. So, how do we actually enforce this? Well, think of Claude kind of like a brilliant but brand new employee. You have to be explicit. By setting the role to service desk analyst and giving strict output rules, like asking for concise bullet points, we create a boundary. This is what we call a contract-style system prompt, and we feed it right into Claude to establish the rules of the game. We just take that vague VPN is dropping complaint, run it through this prompt, and Claude instantly fires back a perfectly structured ticket that is 100% ready for the engineering queue. Which brings us to Section 2, Finding the Root Cause. So to actually fix the underlying issue, we have to move way past basic triage and really dig into the raw logs to hunt down the bug. Because a ticket tells you what is broken, but the logs tell you why. Now, usually, this means a human has to manually sit there and sift through thousands of lines of code. But what if we wire Claude directly into our observability tools to do all that heavy lifting for us? Here's where it gets incredibly cool. We can prompt Claude to simultaneously analyze distinct data streams from our logs to generate a highly specific root cause hypothesis, not just a generic guess. For example, we feed Claude Stream 1 observability metrics showing error rates climbing to 2.3% with the CPU hitting 94%. Then we give it Stream 2 recent change events, like a Kubernetes deployment that happened to roll out exactly 1 minute before the errors started. By cross-referencing these, Claude's reasoning engine connects the dots in absolute seconds. I mean, just look at how Claude can pinpoint something as hyper-specific as an RTP timeout or a session refresh timer failure directly from raw text. It ingests the bug report logs and accurately concludes that timer duration is 0 errors were causing a session refresh timer failure. It even tells you exactly what to do next. Check session refresh timer logic in the source code. Honestly, this is hours of mind-numbing manual debugging reduced to literally seconds. All right, Section 3, Drafting Customer Status Updates. Okay, so we've nailed down the issue internally, but now comes the tricky part, translating this back to the user. It is absolutely vital that we don't just copy-paste raw logs or confusing IT speak to a person who is just waiting to get their work done. If you tell a marketing manager that their session refresh timer hit 0, leading to an RTP timeout, I guarantee you're going to get a very confused, very frustrated reply. What we need here is empathy, clarity, and professionalism. Enter what we call an anchoring strategy. By explicitly telling Claude in the prompt to start with issue summary and end with resolution steps, we are forcing the AI to stick to our brand's specific communication style. It takes that super dense, highly technical root cause analysis from the previous step, and it gracefully translates it into a reassuring, consistent update that the customer can actually understand. Let's put this all together. Section 4, Scenario, Intermittent Payment Failures. Picture this. It's a crazy busy Tuesday afternoon, and you're working the queue. Step 1, a customer drops a message in Slack saying, "My payment failed again." Instantly, Step 2, Claude kicks in. It checks the customer's Stripe payment history, verifies their account tier over in Salesforce, searches Jira for similar bugs, and pulls the necessary logs. Step 3, it generates a perfectly formatted, high-priority Jira ticket for the billing team. And finally, Step 4, it drafts that anchored, friendly status update so the customer knows we're on it. The flow is just incredibly smooth. Finally, Section 5, the before and after comparison. This right here is the ultimate payoff. A totally useless two-line Slack message instantly transformed into a fully structured Jira ticket complete with an RCA draft. Before, a human agent would have had to manually triage that vague sentence, ask a bunch of follow-up questions, log into Stripe, verify the timeout, and write up the ticket from scratch. Now, the output is an urgent priority ticket, the exact API timeout is logged, the business impact is quantified at over 200 transactions, and your customer update is just sitting there waiting in your drafts folder. The AI didn't just route the ticket, it practically did the entire investigation. So now that you've seen how to completely automate the busy work, the only real question left is what you're going to do with all that reclaimed time. By using Claude to enforce those contract-style prompts, run root cause analyses against your logs, and draft those anchored customer responses, you aren't just shaving off a few minutes per ticket. You're fundamentally upgrading your entire support operation. Just think about the massive systemic issues you could proactively solve if you weren't stuck doing manual data entry all day. So what's the very first ticket workflow you are going to automate today? Keep learning, keep experimenting, and I will catch you in the next explainer.